Michael Larsen. If you are interested in following my shenanigans, I am MKL Test Head on Twitter. I work with a company called Learning Technologies Group. They're based out of Bristol, England. I work for their division called PeopleFluent, which is based out of Raleigh, North Carolina, but I personally work out of my house in San Bruno, California. So I'm very, very dedicated to the fact that things can be done remotely and in unique and creative ways. And that's part of what we're going to be talking about today. So this talk is all based on self-healing automation, a remedy for failing automated tests. Do notice the question mark at the end, because that question mark is very important to the context of this talk. So I want to tell you what this talk is not, okay? This talk is not an in-depth tutorial about self-healing automation. I can't do that in a half hour no matter how hard I try. This is not an expert developer's reflections and recommendations of best practices. I am a software tester when you get right down to it. I am not a long-time seasoned developer. I do not pretend to be. And also, I am not going to give you any endorsement for any particular approach. There's lots of ways of doing it. No one way is absolutely correct. It depends on the context and the way that you plan on doing it. What this talk is about, however, is the experiences of a tester exploring self-healing automation, some possible skepticism about the hype surrounding the term, an explanation of what self-healing automation appears to actually be, and I'm going to show you an example that you can literally take home and try yourself, and it will cost you nothing. All right, so what leads to flaky tests? Again, I'm going to use the slides more as a guideline. I'm not going to necessarily talk to them exactly. But the point is, automated tests are really necessary for things like successful build and deployment, Jenkins pipelines, et cetera. You can deal with flaky tests if you're just casually testing or you're looking through some certain things to see if something works. If you have it in your actual build pipeline, you can't afford flaky tests. So when tests go bad, they cause failed builds. You have to research them, examine them, and if you've got a real error, of course, you're going to need to fix it. Oftentimes, though, what you're going to run into is that tests aren't always flaky because you've got an actual problem with them. Oftentimes, you run into issues of latency. You run into issues of the software not loading fast enough for you to actually get your test to work correctly. Or you just realize that the nature of how a dynamic test will actually render on your page. And the more complex those interactions become, the harder it is to predict whether or not you're going to get it right. And that leads to flaky tests. So can't they just figure these things out on their own? Sort of seems like that's what self-healing automation is all about, right? It can just figure it out, and it will just fix itself, and it will just move on. Anybody think that that's what self-healing automation is like? Or you get the impression that that's what it's like? Or you get the impression that that's what the marketing's trying to lead you to believe? Come on. Yeah, thank you. Because that's what they're trying to indicate. It's a buzzword, and they're really trying to get you to think about that. So, can your tests figure this out on your own? The answer is yes, they can. To a point. And the to a point is what I plan on really hammering home here. Okay? Oftentimes when we think of test automation covers a lot of ground, but for our purposes, and probably many of your purposes, you're focused on Selenium, you're focused on WebDriver, you're focused on driving a web page, interacting with it, making the GUI work. Now, we could have arguments all day long as to how valuable those tests actually are. Part of me would say, really, I would look at a test like that and say, does it make sense to go through and automate a whole bunch of factors on the page to make sure we can get to everything? Maybe. Does it make more sense to actually punch our API and see if we get the right values back? I mean, call me kooky, but running a series of API tests is a lot faster and it's a lot more precise than trying to figure out where you're going to click on a page through a automated framework system. But you can still do it. That's not the point of this, though. You know, for our purposes, many times we need to use the GUI tool because that's what management has told us that we need to work on. And because we need to do that, okay, fine, let's go in, let's go poke around on the page. And for those, you need locators. You need things that are defined by your document object model, and you need to be able to actually focus on their presence, interact with them, or just verify that they're there. If you do an assert on a locator, if it passes, it passes. If you do an assert and it can't find it, test fails. Problems arise when we can't guarantee what those values are, or there's a chance the values might change. If you're doing a dynamically loaded page, I'll give you a little bit of a hint. In the example that I show, I do an example using an Amazon search for a very specific product in a very specific configuration, which means your number of choices is very limited. So you would think that you would always be able to get a successful run. And yet, this test that I've run for months under the same parameters, sometimes it passes and sometimes it fails. And the reason is, it's not that it fails because the value that I'm looking for isn't the right value. It's because it appears at random places on the page. Because I've run this test so many times that Amazon is actually starting to put things in and go, hey, you seem to like this product. What if we introduce this to you? Now that's a part of your test you might not have ever considered. What do I do when Amazon's getting so sick of me running this that they're actually entering information in that I never asked for? This doesn't match my search criteria, but yet you're putting it in because it kind of goes with it. So you might want to buy it. What they're interested in is, we want your engagement. What am I interested in? Can you find the item I'm looking for? We're testing at cross purposes. And that's sometimes how you test fail. So if the idea of tests that heal has you raising a skeptical flag, I applaud you. Because, let's face it, a computer is not an organism. Self-healing tests are not magic. They are not organic. You can't cut a test and it can't magically mend itself. And then, as like nothing had ever happened. They have no healing powers at all. What they do have, self-healing tests have the ability to make Hobson's choice using Occam's razor. It's worth a try. I'm just showing my age. The point being is that what they're really doing is they are leveraging artificial intelligence and machine learning to perform decisions under the hood, okay? And again, you'll notice artificial intelligence and machine learning is in air quotes. Actually, no, here it's in quotes. That's air quotes. So let me give you a 5,000-foot view of what self-healing technology is supposed to do, okay? Tools operate under the principle of making small tests and comparisons, multiple times. Those comparisons create variable values that we refer to as agents. And when an agent is first created, it's given a value. Over time, that value is modified up or down based on your interactions. That is the simplest definition of machine learning I will ever be able to give anybody. Because that's all that it is. You create an array. You create a number of values. Each value is associated with some piece that you want to query or verify that it's there. A locator, for example. If you run a test and the locator shows up and your test passes, that agent increments its value. In other words, you're giving that locator more presence. It matters more. The agent is determining that it matters more. Now, if you run that test again and it fails, then that agent is decremented. And if another variable gets pulled in and run and that locator successfully passes your test, then its agent is incremented. And over time, what you're going to see is you're going to have all these agents and they're going to move. And they're going to be stacked up. And 100 tests run, you might have agent A is your most important one, agent B is your next most important one, and agent C is your third one. But after you run it 200, 500 times, agent A may have dropped because it's not as reliable, whereas agent C is now super reliable because it's getting all the hits. And B, you've realized, has changed, so it doesn't matter anymore, and you can pull it out of the list and let something else get a value. Script and its underlying libraries have the ability to adapt and try different things. The level of complexity, of course, can and will likely grow. So with machine learning, it's not like you have a little limited batch of agents. It's everything. It's all of your locators. And if you start running hundreds or thousands or tens of thousands of tests, then what you are doing is you are keeping track of tens of thousands or maybe hundreds of thousands of agents. And those agents get a hierarchical rank, and over time, again, you're focusing on which ones are more reliable and which ones are less reliable. So the key here is, again, if you are looking at locators and you're looking at ranking locators, then they have to be pulled in. If you're going in and say you're looking at a username, and you're only looking for that username, and if you get a successful pass, you're good, but if you get a fail, well, you're not looking for anything else. So in this case, an agent's not going to help you because you have a hit or miss chance of 1. So ultimately, if you keep running the test, you might actually bring your agent count to 0, but it's got nothing to compare to, so it doesn't really matter. But in this case, you can have a set of locators, IDs, or CSS classes, or XPaths, names and labels. And also, you can run the ability of having lots of parameters or attributes that you want to keep track of, not just the one. So let's say, for example, we have a username, and a developer changes it to initial username. Now, if you're only doing the one-to-one example and you're looking for username literally, just that label, it's going to fail. Done. It's just going to. Now, you could go in and say, oh, they changed it to initial username. I'll just go in and I'll change my tests. Can you do that? Yeah, sure. If it's spread out over hundreds or thousands of tests, that's going to be awfully time-consuming. So you probably wouldn't want to necessarily say, I want it to be this specific name. Now, you could say, I'll put a regex pattern in instead, right? That's another way that you can deal with this. You could say, I only care about the one value, but I can modify my test so that what that one value is, if the value changes, as long as this little piece stays the same, then I'll be in the clear, and that's okay. But again, is there any guarantee that it will? No, not necessarily. And so if they take that little piece you're relying on and it's no longer valid, then you're back where you started from. So what you want to do instead, and what SelfHealing Automation encourages, is to capture or understand multiple aspects of a web element and how to interact with it. So the best way you can do this, I'm sure that you've done this many times. You go and say, hey, I want to look for this item on this page. You go and you click on it, or you grab a link, or you look for a text box, and you open up and you click inspect. And what do you get? You get the DOM for that element. And if you look at the element, you can click on it, and then you can see the hierarchy of what precedes it, or how many things go before it, right? Or you can actually see that you have an element, and it's got an ID, but it's also got a name, it's also got a CSS class, it's also got a, it's got a label, it's got alt text, I mean, fill in the blank. So all of those attributes can have identifying aspects to them, and you can utilize every one of them. So if you can't get there by name, try the CSS class. If you can't get there by the CSS class, try the XPath. If none of those work, what's the upper level node that the identifier is associated with? Okay, you've got a label. What's the label associated with? Oh, it's located within a text box. Where's the text box associated with? It's located within a form. Where's the form located? It's located within a table. Where's the table located? It's located within an iframe. Where's the iframe located? It's located inside of another iframe because it's being called up, right? You get my point. You have this whole hierarchy that you can dance through, and so if you can't find the individual item, you can step backwards and say, how about you? Okay, good, I found you. Now, how about the item I'm looking for? Hey, great, now we've got it. What happens to that item up above? Its agent count goes up because it's now a reliable source, at least that time. More times we run this test, the more times it gets called in, the more times the agent count gets boosted. All right, so this is the example that I like to use. And this is what I was looking for. So a little bit about me. I'm a musician, and I also have a home recording studio. And in the process of building that home recording studio, back when I initially did this article, I thought, hey, you know what? Just for the fun of it, since I'm already shopping for an interface, and I want to kind of see what's out there, let me make my example shopping for the interface. So what I did was, I picked one, and again, I picked a very specific one. This is the Focusrite Scarlett 8i6. Any of you out there who are music nerds might be going, yeah, that's a good one, or wait, what? Why? I happen to like it. But anyway, that's what I decided to use as my example. So Focusrite Scarlett 8i6, that's a very specific product. It's fairly easy to locate. And so what I did in this example, and if you want to play along at home, you want to try this out and see how this stuff works, I picked Testim using the Testim editor because it's free. And you can get an initial handle on how this stuff works. And the Testim editor is, I mean, you can get it in a number of ways, but I use it as a Chrome extension. Just it's built into Chrome. I log in and I just go with it. It's meant to be an interactive tool. You can export the tests you create if you want to edit it in an IDE in a preferred language. But for most introductory cases, and if you're getting used to it, it's easier to use their editor, so I would encourage that. It's pretty quick. Record a new test, go to Amazon.com, and in this case, search for Focusrite Scarlett 8i6. And then go through and set up your test and set up the values you want to look for. So in this case, I looked for, and I said I want to focus on Focusrite. I want just their brand. I want to get the Amazon Choice package for it. And I want to make sure that I'm looking for this very specific string of text. Exactly. That should limit my choices down really small. And that's exactly what I was hoping to see with this. Go down and say, cool, run that through, save my test. And when it's done, it's going to look something like this. It's going to show you exactly what it's looking for, what it's validating, and all the options that you would need to do to run your test. Here's where it gets interesting. Remember how I told you before that they had all these locators that you could work on? As an example, this is a list of the individual target that I picked. Just one. I picked one target. Notice, you have a whole bunch of elements that are associated with them, and each level that they're associated. These star counts are basically your agent accumulations. If I were to go run this 300 times and go look at this list, I guarantee that ranking would be different because of what it would have to interact with. So it's going to go through, jump, 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 and make sure that it can get okay. Now, what downsides might you think you might have with this kind of approach? So we're giving it the option to say, okay, I can't find this, so let's go look for this one, or let's go look for this one, or let's go look for this one, or let's jump up a node and look for this one, or let's scrape the page and look for all of the nodes in succession. What are we introducing into the system when we do that? We're introducing latency, right? We're introducing time to execute because it has to go through each one of those. Now, mind you, in a typical single test, we might be adding 500 milliseconds or maybe a second and a half when you add that all together. That doesn't sound like a lot. It really doesn't feel like, oh, big deal, so I could run a test in 1 second and it takes me 2 seconds to run it. Is that really a big deal? Well, ask yourself. Maybe not for one test. What if you have to run this test 10,000 times, 100,000 times? Is that 1 second important to you now? Yeah, it can be. So one of the things you want to do when you consider these tests is you don't want to leave it completely open and just say, hey, I've got self-healing. You know, it's like you don't necessarily want to go into the emergency room if you cut your thumb, right? A Band-Aid and a little bit of Neosporin is really all you need. However, if you get a gunshot wound, you want to make sure that they take care of you to the utmost of their efficacy. So you need to be judicious with how you lay this out. If you have a simple test, you might only want to have a few parameters. If you have a really complex test or one that requires looking at a very dynamic system, then yeah, you'll probably want to take that hit and have a lot of options for how you get to those elements and how you confirm them. Or if you want to make absolutely sure that your failure is reasonable and what you actually want it to be, then you can say, even with these 3 or 4 options, I want to guarantee that we get a failure here. Now, we don't want a failure because we can't find something. We want a failure because 2 plus 2 is equaling 5, right? I mean, yes, if you get an example of 2 plus, wait, what? I don't have that value, that's just as bad. But if you wait a little bit, you might get the other 2 and then make it equal 4. So the point here is the principles behind user agents are pretty basic, but the key thing is that, just like I said, the devil is in the details. Run too many of them, it will take you too much time. Don't run enough of them, you might get false positives. You might have fails that really aren't failing, you just can't find what it needs. Or you can make sure that your tests pass 100% of the time, but you're not looking for the right thing because what you were looking for previously is now being covered in a global, right? If you have an asterisk, I'm looking for every file in my system. Oh, hey, look, I got a file. It passes. I mean, yeah, technically, but is it a worthwhile test? All right. So in conclusion, self-healing automation, it sounds like magic. But let me assure you it absolutely isn't. It is merely giving your tests multiple opportunities to be successful. Self-healing automation is a technique that can be used. You can use it today. You can use it with a number of applications that are out there. You can mix it into your Selenium tests with various libraries if you so choose, and you can just turn it on, and you can see how it works for you. Okay. While I cannot promise that all of your tests will pass or that flaky or brittle tests will not still be a reality, if you looked at that very beginning picture that I showed on my screen, that wasn't my actual run of that Focusrite test. I've been running that test daily since I first started looking at this back in January. It was last run this morning. And I will keep running it because, again, my whole point is I check up on it and I want to see how has that agent listing changed. And the answer is it does change. So it's proof that the self-healing technology is working. But self-healing, not really. Deliberately opportunistic? Yes. But let's face it, that's not nearly as cool a marketing, right? Thank you very much.